Building at the speed of AI. How P6, JEPA, Alice and Doxel transformed the Skyline Tower. Welcome to the deep dive. Today, we're zeroing in on something pretty exciting in construction AI and how it can really speed up project timelines. It's a big topic, and we've got a great case study to dig into. The Skyline Tower, a massive 45-story mixed-use building where the goal wasn't just building big, it was building fast. The team didn't just dabble with AI. They went all in, integrating 3 advanced AI technologies with their existing project management software, Primavera P6. Their mission was clear. Take a standard 36-month schedule, which is already pretty tight for 45 stories, and crunch it down to just 28 months, a 22% reduction. Really ambitious stuff. So what were these AI tools? They brought in the heavy hitters. First up was Alice Technologies. Alice is all about optimizing schedules, generating tons of different ways to build something, exploring possibilities. Then you had Doxel. Doxel uses visual data cameras, drones to automatically track what's actually happening on site, providing real-time progress verification. The third was JEPA, Joint Embedding Predictive Architecture. JEPA is the prediction engine. It learns from all sorts of project data, the schedule, progress tracking, weather, materials, to give predictive insights about what might happen next. So we have optimization, tracking, and prediction, the trifecta. What's really interesting isn't just the tools themselves, but how they actually work together, feeding information back and forth. That integration is key. It wasn't just 3 separate experiments. Let's get into it. Where did they start? The baseline P6 schedule. The original P6 plan was the foundation before any AI touched it. 36 months duration with a pretty standard sequence. Foundations first, then the main core structure, then getting the MEP risers in. That's mechanical, electrical, plumbing, and finally commissioning and testing everything out. Resource-wise, they were projecting a peak workforce of about 385 people on site, and the hoisting equipment, cranes, lifts expected to be busy around 92% of the time. Pretty typical for a big job like this. Then Alice comes into play. Step 1. Get that P6 schedule into Alice. Then you tell Alice about the project constraints: 45 stories, 3 tower cranes, 4 hoists, and the build method, which was core first. Build the core, then follow with the floors. After setting these basic rules, Alice does its magic through 50,000 simulations. It's basically Alice trying every conceivable way to sequence the work, allocate crews, and use the cranes and hoists within those rules. It explores this huge possibility space, different ways to link tasks, different crew sizes, different equipment assignments. For every single simulation, it calculates the time, cost, and resource use, and finds the best ones based on the project goals. In this case, speed was paramount. The impact was big. Right away, Alice's optimized plan came in at 31.5 months, 4.5 months saved just from smarter sequencing and resource allocation identified by the simulations. The critical path changed too. It found ways to do some foundation work in parallel. It needed slightly more workers at peak, up to 420, but that suggests a more intense, shorter burst of activity was more efficient overall. The cranes and hoists utilization jumped to 98%, getting way more value out of that expensive equipment. Let's break down how Alice achieved those savings through specific strategies. For foundations, the original plan was sequential: dig here, pour here, move on. Alice looked at the site layout and suggested splitting the foundation into zones so work could happen in multiple zones simultaneously. They just had to change the activity relationships within P6 to allow for that parallel work. That alone shaved off 1.3 months and changed the critical path dependencies early on. For the core structure, which is usually a big driver, the original plan was 1 floor every 6 days. Alice simulated different crew mixes, formwork systems, and concrete pumping rates, and found they could hit 1 floor every 4.5 days. Seems small, but over 45 floors, it adds up fast. 2.2 months saved directly on the critical path. The facade, putting the skin on a 45-story building, typically takes ages. The default plan was bottom to top, which would take about 12 months. Alice suggested a multi-zone parallel install start cladding in 3 different vertical zones simultaneously. This requires careful planning, but Alice figured out the optimal zones and sequences. They updated P6 with these parallel sequences and saved 3 months on the facade duration, 2 of which were critical path savings. Same story with MEP systems: mechanical, electrical, plumbing usually done sequentially, floor by floor or area by area, with lots of potential for clashes and delays. Alice evaluated thousands of trade sequencing options and recommended shifting to system-based parallel work, like running all the main electrical conduits vertically, then branching out, coordinated with plumbing runs. This meant better coordination and sequencing. They restructured the MEP activities in P6 based on Alice's findings and saved 2.5 months overall, 1.5 months on the critical path. For the floor cycle, the time to complete a typical floor, the standard repetitive cycle, was estimated at 8 working days. Alice analyzed all the tasks within that cycle and optimized crew sizes and equipment allocation for each task. It calculated they could consistently hit a 6-day cycle, saving another 2.8 months on the overall project duration. So Alice provides this super optimized plan in P6, but plans change, things happen on site. That's where Doxel comes in. Alice gives you the best possible plan. Doxel tells you what's actually happening day by day and feeds that reality back into the system. Doxel was set up with a comprehensive camera system, fixed 360-degree cameras on each floor capturing images daily, weekly drone flights for the big picture, especially the exterior, and field teams with mobile 360 cameras for specific checks. Connecting this visual data to the P6 schedule was detailed work. They had to map specific building elements visible to Doxel's AI, like beam type A, section of ductwork B, drywall panel C, to the actual activities in the P6 schedule. Over 2,000 elements were mapped. Then they set up rules like, if Doxel sees 90% of drywall panel C installed in this area, update P6 activity, install drywall zone 4 to 90% complete. Crucially, they automated this update process. There was a clear protocol: daily fixed camera captures, weekly drone flights, daily supervisor walks with mobile cameras. They also had to train Doxel's computer vision by feeding it tons of images so it could reliably recognize specific beams, pipes, walls, etc., and calibrating it to measure progress correctly for different kinds of work structure, facade, MEP. It was a lot of upfront effort to get it working right. The big wins from using Doxel were significant. First, automated progress verification. Before Doxel, someone spent 2-3 days a week walking the site, checking progress, updating the schedule manually. Doxel did it daily, automatically, with 98% accuracy, saving about a day per week in admin time, around 12 days saved just from automating the check-ins. Early issue detection was another huge benefit. Instead of finding a problem at the weekly meeting, Doxel would often flag deviations within 24 hours, like a wall framed in the wrong spot or structural steel not matching the plan. Catching these things early, before they get built upon, is massive. They estimated this saved about 18 days total by preventing bigger delays down the line. Doxel also provided objective data, no more relying on someone's gut feeling about progress. It gave hard numbers. We installed X square feet of drywall, Y linear feet of pipe, taking the guesswork out. This improved productivity by 15% because they had clear objective measures of performance, translating to another 22 days saved. Quality improved too. The AI could spot potential quality issues during installation: incorrect spacing, wrong materials, helping reduce rework significantly by 70%. They estimated that saved another 15 days. So Alice optimizes the plan, Doxel tracks reality, and now JEPA brings the predictive layer. JEPA acted like the central brain, pulling data from everywhere: the P6 schedule, real-time progress from Doxel, even the parameters Alice used for optimization. But it went beyond just those internal systems, integrating external data too: detailed weather forecasts, material tracking systems, workforce management data. With all this data, JEPA built models to forecast weather impacts, not just rain, but high winds impacting crane work on upper floors, predicted productivity rates for different crews, assessed the risk of material deliveries being late, anticipated equipment breakdowns, and predicted potential clashes between trades. And this wasn't static. JEPA kept learning, constantly comparing its predictions to what actually happened, then refining its models. It got smarter as the project went on. These predictions delivered significant time savings. For weather impacts, instead of just reacting when rain stops work, JEPA gave advanced warnings up to 5 days out so they could reschedule that concrete pour, shift crews to indoor tasks. This proactive planning resulted in an 80% reduction in weather delays, saving 18 days. For resources, people and equipment, JEPA analyzed past performance and upcoming work to predict the optimal crew size and equipment needed for specific tasks day by day. This more dynamic allocation led to a 12% improvement in resource efficiency, saving another 25 days. Supply chain issues are killers too, materials not showing up on time. JEPA helped by predicting delivery reliability. It learned which suppliers were typically late and factored in lead times and transport issues so they could tighten up delivery schedules. This meant less waiting, less need for huge safety buffers in material orders, more just-in-time delivery. They cut material waiting time by 85%, saving about 14 days. JEPA also flagged potential trade conflicts before they happened on site. It analyzed the schedule and spatial data so site managers could resolve issues beforehand. The system often suggested solutions like slightly shifting one trade's start time, preventing a lot of on-site standstills. This reduced coordination delays by 65%, saving another 20 days. P6 became the central hub, constantly getting updated by these AI systems. Alice fed in the optimized plan, Doxel fed in real-time progress, JEPA fed in predictions and warnings. It was a constant flow of information, transforming P6 from a static plan to a dynamic control center. They even customized P6, adding new data fields specifically for the AI info, things like Alice optimized duration right next to the original duration, Doxel verified percent, Doxel quantity installed, JEPA predicted finish, JEPA confidence level, even JEPA risk factors. So for any task, you could see the original plan, the optimized plan, the actual progress, the prediction, and the risks all in one place. Imagine looking at install core wall reinforcement, floor 25 inches, you see plan, 5 days, Alice optimized, 4 days, Doxel verified, 75%, JEPA predicted finish, Tuesday, 4 p.m., JEPA confidence, 95%, JEPA risk, potential rain delay Thursday. That's incredibly powerful information for a site manager, instant, game-changing visibility. Adding it all up, the impact on the project timeline was impressive. Pretty much every phase got faster. Foundations 1.3 months quicker, 29% acceleration, structure with a huge saving of 3.2 months, 25% faster, MEP systems 3.5 months cut, 22% faster. The grand total, 36 months down to 28 months, 8 months saved, hitting that 22% acceleration goal. The milestones shifted dramatically. Foundation complete 48 days early, structure topped out 99 days ahead of schedule, building dried in 106 days early, MEP systems complete 117 days early. And the big one, TCO, temporary certificate of occupancy, when they could start moving people, and achieved 238 days earlier than the original plan. That's almost 8 months of massive acceleration, showing how the savings compounded through the project. Getting this all up and running wasn't instant, it was a structured 4-week rollout. Week 1. Initial integration, getting the P6 data into Alice, setting up Doxel mapping, initializing JEPA models. Week 2. Schedule transformation, importing Alice's optimized plan back to P6, configuring Doxel's tracking rules, deploying cameras and drones, initial JEPA training. Week 3. Field implementation, training the site teams, starting daily data captures, setting up autosync between Doxel and P6, getting supervisors using JEPA's insights. Week 4. Full operation, Daily auto updates to the schedule, starting regular weekly AI optimization cycles, using JEPA for proactive risk analysis, launching the executive dashboard. That dashboard was key for management visibility, showing real-time KPIs, schedule performance index, production factor, critical path buffer, resource efficiency, JEPA's confidence in hitting completion dates, weather impact forecasts, material delivery predictions, heat maps showing potential trade conflict zones, productivity trends, and even AI-generated recommendations for action. The big question: cost versus benefit. Was it worth the investment? The total investment for software, hardware, implementation, and training came to about $1,350,000, not insignificant. But the savings were huge. Reduced general conditions cost because the project finished 8 months early, lower financing costs, early completion bonus, better resource use, way less rework cost, reduced need for risk contingency funds. Total estimated financial benefits: $9,950,000. That's nearly $10 million in benefits on a $1.35 million investment. The net benefit was $8.6 million, giving an ROI ratio of 6.37 to 1, with a payback period of just 4.2 months into the project's duration, a very fast payback. Looking back, the biggest lessons and critical success factors included: a unified data environment was crucial for getting the systems talking. Field team buy-in was essential as they had to use the tools, implementing incrementally, not all at once. Executive support was vital, and good quality data to start with, garbage in, garbage out, even with AI. They faced challenges too. Initial data quality in P6 needed cleanup, there was some resistance to change, a learning curve with the new tech. Integrating the systems wasn't trivial, and crucially, remembering that AI assists, it doesn't replace human judgment and oversight. Their advice for others thinking about this approach: start early, ideally in pre-construction. Clean up your P6 schedule first. Involve field leadership deeply. Make the tools user-friendly, especially mobile interfaces. Keep data synced daily. Do regular AI optimization reviews. Validate the predictions to build trust, and document everything you learn. This Skyline Tower story is really compelling. It's not just about speed, it's about a more reliable, efficient, less risky way to build. It's smarter construction. The ROI speaks for itself, building a strong business case for adopting this kind of integrated AI. It really does change P6 from just a planning tool into a dynamic, intelligent management system, a fundamental shift. It makes you wonder, if this works so well in construction, what other industries could benefit from this integrated approach of optimization, tracking, and prediction? Think logistics, manufacturing, maybe even healthcare or resource planning. The principles seem broadly applicable, though different industries would face different hurdles and opportunities. Thanks for joining us for this deep dive into how AI is transforming construction project management.